When you have oil from a diesel engine system analyzed, it's like visiting your doctor for a checkup. The oil analysis enables those who understand the report to confirm that all is well. Alternatively, an informed diagnosis can be made of a developing mechanical problem or chemical imbalance. As you'll see in this module, acting on the diagnosis can often extend the patient's life. Donaldson Oil Analysis, a service performed by independent laboratories, provides the quality testing necessary for effective preventive maintenance. Our objective is to facilitate fast and highly accurate information which indicates the status of our customers' engines and equipment. You can use our data and recommendations to improve your preventive maintenance and reduce your equipment downtime. The data can also be used to decrease your overall cost of lubricants by extending your oil drain intervals. What would happen if you simply ignored the levels of impurities in your engine oil? The contaminants whose levels are constantly rising in diesel engine oil can be broadly grouped into 6 categories. The first is ingested dirt, which can enter the engine through the air intake, a failed engine gasket, or contaminated fuel supply. Ingested dirt appears primarily as silicon. As the silicon levels increase, engine wear increases. The second category is wear elements, the product of internal engine component wear. Typical wear elements are copper, iron, chromium, lead, aluminum, nickel, molybdenum, and magnesium. Soot, the third category, is really partially burned fuel. Soot is introduced to the oil by operating an engine in too high a gear, known as lugging, or by improper timing, intake or exhaust restrictions, or engine idling. Also, with newer emission-compliant engines, soot can increase from blow-by gases and EGR systems. As the oil degrades, soot can agglomerate and form clumps that increase wear. Excessive soot will also adversely affect oil viscosity. Since the introduction of exhaust gas recirculation, or EGR, soot levels in some engines can be the limiting factor on oil change intervals, because soot levels in the oil have increased significantly. Fuel in the oil is fourth on the list, and is caused by such factors as worn injectors, or a line leak, plugged air filter, or improper timing. Fuel in oil will thin the oil, reduce oil pressure, and allow harmful metal-to-metal contact. Excessive fuel in the oil may even lead to a fire or explosion. Water is produced by combustion and is usually carried away with the exhaust. In cold engines, however, water can condense in the crankcase. Water can also be ingested when adding oil. Water in engine oil promotes acid production, which leads to corrosion and wear. Coolant, the sixth contaminant, enters engine oil through a bad seal, pitted liner, cracked head, engine block, water pump, or EGR cooler leak. On engines with EGR, the exhaust gases need to be cooled before being reintroduced into the combustion chamber. This is accomplished by the use of an EGR cooler, which uses coolant to reduce the temperature of the exhaust gases. Coolant in the oil causes glycol sludge, which plugs oil lines and filters and causes rapid additive depletion. To take advantage of the Donaldson Oil Analysis service, simply follow 5 important steps. Collect the oil sample by removing it from the engine or component while it is running, if it is safe to do so, or within 30 minutes after shutdown. The sample should represent the true condition of the lubricant at the time of sampling, or the reliability of the test results can be dramatically affected. Do not take the oil sample from areas where oil flow is restricted or where contaminants and products of engine or component wear tend to settle and collect. Accessories, such as a sampling pump and quick sampling valve, are available through your local Donaldson distribution outlet. Once a proper sampling point and method is chosen for a particular component, Oil samples should always be taken from the same point, using the same method. The first step is to complete the mostly self-explanatory sample processing form for each sample. Secondly, be sure to inform the laboratory of any mechanical or operating problems experienced with the sampled system. Step 3 is to accurately label the sample, taking care that it matches the data on the processing form for proper identification of the sample. Then send the sample to the lab using a rapid delivery service. We recommend sending the samples in quickly rather than holding them. The final step is to review the lab report when it comes back to you or to view it online. Verify your equipment identification on the form. Next, look at the elemental analysis or spectrochemical analysis in the columns of data. This identifies the type and amount of wear particles, contamination, and additives in the sample. Measurements are expressed in parts per million. Determining metal content can alert you to the type and severity of wear occurring. This is why it is important to supply full details about the unit from which the oil is being tested, including its work environment. Once you have started sending in samples from a particular engine for Donaldson oil analysis, an ongoing record is started. Successive reports will repeat earlier report data for comparison and trend management. Excessive levels of dust and dirt can be abrasive and accelerate wear. Highlighted numbers in the columns denote test results that the analyst has flagged because they exceed preset warning parameters and warrant closer examination or require action. Individual results are noted to better explain the overall severity assigned to the sample. In the special testing section of your report, note these additional measurements. Fuel, soot, and water results are all reported in percent of volume. High fuel dilution decreases the load capacity of the unit tested. Excessive soot is a sign of reduced combustion efficiency. Water in oil decreases lubricity, prevents additives from working, and facilitates oxidation. The total acid number, or TAN, is the amount of acid present in the lubricant. TAN numbers higher than that of new lube oil indicate oxidation or some type of contamination. The total base number, or TBN, measures the oil's alkalinity, or ability to neutralize acid. When TAN and TBN approach the same number, the engine oil should be changed or sweetened by adding more oil. Donaldson recommends following the sampling frequencies set by your engine manufacturer. If they are not available, follow these sampling frequency guidelines. For mobile equipment in regular use on-road, sample at these intervals. Diesel engines, sample at 10,000 miles or 16,000 kilometers. Gasoline or petrol engines and LPG engines, sample at 3,000 miles or 4,800 kilometers. Non-engines at 20,000 miles, 32,200 kilometers, or 500 hours. For mobile equipment in off-road use, sample at these intervals. Diesel engines at 250 hours. Gasoline or petrol engines and LPG engines at 150 hours. Non-engines at 500 hours or monthly. In marine applications, main engines at 250 hours or monthly. Support engines at 150 hours. Non-engines, 500 hours or monthly. With industrial or stationary diesel or natural gas engines, sample at 500 hours or monthly. Engines that are used intermittently should be sampled quarterly. This servicing information is provided as a best practices guide. It is not, however, intended to replace or supersede the service instructions supplied by your engine or vehicle manufacturer.